let's talk about the difference between function versus relation. So a function is a relationship where each x value has exactly one y value. Where relation is kind of a broader understanding as that many outputs have a single input. So if you think about going to a concession stand and everything's $1. A relation is an example of where if I give them $1, I could get a Twinkie, I could get M&Ms, I could get a Gatorade. That's relation, okay? There's many outputs for that single $1 that I put in. We use things like this as like if I can pick as many donuts that I want for each a certain price, or 5 for $1, whatever, no matter what the donuts are. Where other days it may not be on sale and I have to pay a certain amount for chocolate versus caramel or whatever. Now, functions are more specific. So there are certain rules that they have to follow to be considered a function. So what makes up relational functions are elements, inputs and outputs. We know inputs as domains, those are our x's. So everything that we put in is an x. And we know outputs are y. What we get out is our output or our range. Those are all our y values. And you've learned in science, independent and dependent, so understanding what those are as well. So we can think about ways that we can display relations are 4 different ways: ordered pairs, tables, graphs, and mapping. And these are a couple of examples of what those look like. So ordered pairs you've seen many times before. This is a set of them. That's what the little squigglies on the outside means, a set of ordered pairs. Then we have a relation in a table. We also have a graph, and then we have it in mapping. Mapping you don't see as much, but you should have been exposed to this at some point. So we're going to talk about ways to know if something is a function, and we're going to use these as an example. So the best way, if it's a graph, is the vertical line test. So you can think about your finger or pencil, and if you look at a graph and you see that if you draw a straight line down, so let's pick a color here. We'll do green. So if I draw a straight line down right through my graph as it was a pencil, I can see I'm only hitting that red dot one time. I'm only hitting something that's on the function one time. I do the next one where that dot is, it's only hitting once. If I hit here, it's hitting 2 spots, here and here, at the same time. That means when I have an input of -3, that's a -3 on the x there, I get out a 1 and I get out a 3. That's saying if I put in, say, $3, I get out 2 different things. That's when a vending machine's broken. So if when you go to those vending machines and you push in like A4 and you should get out M&Ms and out pops a little turkey, something's wrong. It's broken, okay? It's not functioning, okay? If I were to connect all of these lines as a one continuous piece from left to right, so let's say I would connect here, 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 we can easily see that that's not a function, okay? Functions are something that if we had, like say, a straight line and I went through each time, it would only hit that function or that line one time each, okay? So that's a way to see it in a graph. Now, it's easier to see in ordered pairs or a table, and what you have to look for is if the x's repeat with a different y value. So first thing I'm going to do is I'm going to look at my x's. So I have a 1, a -2, a 4, and a 1. Well, I see that this 1 here and this 1 here are the same, so I'm going to look right next door. Those are 2 different things. That's saying when I put in a 1, I got out a -3. So every time I put in a 1, to be a function, I should get out a -3. But when I do it down here, I'll get out a 2. It's not a function. It's not working. On a table, the same way. We're going to look to see if any x's repeat first. So -6 is good. 4, I see a 0, and I see a 0. So when I look, I have 0 gives me out a 6, and then I do a 0 again, it gives me out a 7. That is not a function. Now, if they were to have a 0, 6 and a 0, 6, that's okay. That's still a function. Yes, the x is repeated, but they gave me the same output. So that might give me something like a quadratic shape on a graph. So when they repeat, x's can repeat as long as they give you out the same value. Now, something a lot of students forget or get mixed up is they think that if y's repeat, so let's say I had all these numbers and I had 2's all the way down. Like, for example, right here I have a 7, 2 and a negative 6, 2. Those are 2 different places. It's okay if the y's repeat. I could actually have all different x numbers and all the same y numbers, and it could still be a function. And those would be, depending on what it looked like, a horizontal or vertical line on a graph. Now, in mapping, a lot of times people get confused about what these are, but it's pretty simple just to kind of look. These are my inputs, always what we start with. So 2 goes to 0, so this is like an ordered pair of 2, 0. Negative 5 goes to 2, and then negative 5 has another line coming off that goes to 4. So immediately, when I see x is repeating, it gives me different outputs, I know it's not a function. It's still a relation, but not a function. All right, so now we're going to talk about set notation versus interval notation. So some of you have probably been exposed to this in Math 2. We're going to talk a little bit more in detail. You have to really know because we get into more advanced function graphs and inverses of those, so we have to know how to write them. So we're going to start with what a set notation is. Obviously, it's a collection of elements, numbers, or objects. Okay, and an interval notation is a way of writing that. It's almost like a shorthand to write that, like it would look on a number line or a graph. So we're going to start with the number line. This number line here is -3 to 8, and you don't even have to put the 0 in there. I usually just put the numbers that I'm talking about only. Notice we have an open circle and we have a closed circle. Now, if you remember back from maybe 7th, 8th grade, open circles mean that the number itself is not included. So an open circle would mean something like less than or greater than, but not equal to. Okay, so not included. This is not included in our set. Whereas a closed circle is like greater than or equal to or less than or equal to, and this is included. So that means 8 is included on this. Okay, so we're going to talk about set notation. So we have a whole bunch of numbers that are shaded in between there. Lots and lots of numbers. So we're going to say x, and we use a line, straight up and down, and this line right here means such that. And that's the way we say it, such that. And we're going to start left to right. -3. So we think about all these numbers right in here. These are x's. These are all what our possible x's could be. So -3 is down here and 8 is at the top. Okay. So x's are going to go right in the middle. And we're going to say the number that we're thinking about, any x, could be bigger than -3. And it's an open circle, so we just use, so we say x is greater than -3. That counts for this. And at the same time, because these are connected together in between, it is less than or equal to 8. And we put little squigglies around it, and that tells us the set. So this says a set of all the x's such that x is greater than -3 and less than or equal to 8. So that is set notation. Now to write this as interval notation, we have a couple other ways to think about it. So when we have an open circle, that is a parentheses that we use. Okay? So it's kind of just like a parentheses. Think about almost like it's bouncy. It can keep, kind of going. And then we put our -3 there, a comma. Our top number is our 8. But 8's a closed circle, so we use a solid little bracket. This is interval notation. All right, so we're going to practice a couple of those. And we're going to talk first about the symbols that we use. So when we're talking about inequalities, where we have the number lines with different pieces, we have some symbols that we use. Now, a negative infinity And a positive infinity would be something if I had a number line, let's say I was going from 3 and it went forever. Maybe this was closed. And all of these numbers could be my x forever and ever to infinity. We would write this as 3, it's included, so close bracket, comma, infinity. Sometimes you'll see a positive in front of it, doesn't matter. And we always use a parentheses around that because we don't know where it's going to stop, so we can't put a distinct bracket. Okay, so the parentheses are open. That means they're not included. Those open circles not included. They represent symbols like less than or greater than. The closed included ones are the brackets, represent less than or equal to or greater than or equal to. And then you can have a U, which means union. Now, in probability and other times you may have seen what looks like a kind of an N. It actually means and, okay? So that we won't really see that much because you don't need that in this notation. So U means union. It means like either or. So when we see those in just a minute, that'll make more sense. And I almost think about if I grab both part of the top and kind of pulled them, it kind of can go to both areas and stretch out to touch both sides. So let's look at some examples. We're going to start with something in set notation, and we're going to write it in interval and on a number line. Okay, now this one is a tough one. This is an or statement. So I'm going to start it out as a graph, as a line. Okay, so let's go ahead and make a little number line. And it goes forever, and I can see I have the number 4 and the number 9. So I'm just going to put a 4 and a 9. It doesn't matter about spacing. We're just doing it for our visual. And we're going to go ahead and make our little mark. So we have a included one. So we know that on that one is going to be a closed circle on the 4. This one is a x is greater than, so that's going to be an open circle. Now let's read this. It says x such that x is less than or equal to 4. So less than or equal, that means all of this is shaded. Or x is greater than, all of this is shaded. So x could be either or. It can't be bigger than 9 and at the same time be less than 4. So it's not an and statement. That's how we know it's an or. And it tells us it's an or. And our visual shows us it's an or. So now let's write it in interval notation. So for interval notation, we're going to use that union because this is an or. This is the example we had right here. We talked about an or. So we're going to put, if we think about what's down here going this direction forever and ever, this is negative infinity. This way is positive infinity. Okay, so we know negative infinity always has the little soft, bouncy one, and then comma, 4, and this one's a close, so we do a hard bracket. And then we use the symbol for or, which is our union. Then we start with our 9. It's an open, so we do a parentheses. And then positive infinity, and always open parentheses. So that's what it would be in interval notation. So I'm going to pause the video. Here's a couple others. So I did a interval, and I want you to find the set and graph. And then I did 2 line graphs, and I want you to find the set and the interval for those. All right, check to see how you did. And if you made a mistake, double check yourself. Now, one thing I want to add is sometimes that you will see a symbol that looks kind of like a fancy R. They kind of make it with like a little open, like that. Sometimes a little, more curly or whatever. And this little symbol means all real numbers. And the way that may look in a notation, a set notation, is they would show something like negative infinity, or this is for a interval notation, a negative infinity to a positive infinity. That's all real numbers. Sometimes you'll see that little symbol in place of that. And that's an infinite interval, okay? Now, if I was using this symbol in a set notation, it may look something like this. So let's take this last one, for example. They could write it like a little squirrely, and then they say X. And then instead of just putting the such that symbol, the straight line, they will use this little symbol. It looks kind of like a weird E. This is a Greek letter, epsilon. And it just saying that the set of all X's are members of, that's what that little E is saying, epsilon. And then they'll have that little symbol, real numbers. Gotta make it a little fancy. And then they will have the rest of this written. So they'll have then the such that and say -1 less than or equal to X is less than 4, and close the set. So if you see something like that, that just means a set of X's that are members of the real family, real numbers family, and then they write the rest. It's a lot of extra work to write, so we usually do not write that, but if you see it, I want you to know what it's about. Now, with graphs, you have to know how to write them as well. So if they're in graphs, let's talk about identifying the domain and range. So remember, domains are X's, and I always tell people when you think about if you have an X friend or an X neighbor, which maybe you don't really like a whole lot, you like that dang friend or that dang neighbor. So you can remember X's are the D, and then that makes it pretty easy to kind of remember that ranges are the Y's. If you have a hard time remembering that, start labeling it until you get used to it and know what's what. So when we're thinking about domains, we're looking at X's. So we're going to look from here to here. So we're just looking at where these start on the X's. So what lines up? So the last one here is -7. Go all the way to the end, and that's a +7. So let's go ahead and write our domain first. So we're going to write it in interval notation. So our domain is, and these are included because they're closed circles on the graph, -7 and 7. Our range are our Y's. So we're going to look at the very tip top of the last top of the Y, where it goes all the way up, and the bottom. Now, they don't have circles on them, but they're not open holes, so they are included. And we always start with our smallest number first, so we're going to start with the -6 all the way to 4. And since they're included, they have closed brackets as well. So that's what it would look like in interval notation for the domain and range of the graph there. So let's see if you can do that one. So hopefully you were able to do that one pretty well. We will get some more practice.